Yeah, well, it's not bad, but trying to do it so people can connect. And let me see if I can mute them. All right. I'll mute them, and that thing is out of the way. And good, and this thing is projecting. We're in business. So I have a little bit of time for the news. Let me put up this.
Good news?
Good news. I don't do good news very much. Although it depends on how you look at good. There's interesting vulnerabilities, like Docker just got hacked, which is pretty awesome. What's that?
I heard about that.
I know, but there's not a proof of concept. But I looked at the description, and it sounds so simple. I think maybe I could write the code and see. They just tell you what to do in general terms. I'm hoping somebody will publish a proof of concept for me pretty soon.
Do you want to do it tonight in the lab?
Well, that would be nice if you think you can do it.
Yeah.
They say what to do, and it looks relatively achievable, but I haven't tried to write it. Yeah, if you can make it going, that would be awesome. Anyway, 225 is, wait, today's 211. Okay, so I just want to put the schedule stuff up here today. Project 4 due. And 225, project 3, 5, and 6 due. I extended the deadline for project 3 because there was a problem with project 3. People told me dogpile. When dogpile became secure, so you cannot get the picture that you're supposed to see. So I changed it to another site, Hackathon, and therefore some people may be stuck on it for a reason that's not their problem, so I delayed the deadline. Anyway.
I'm actually having a problem with Hackathon. There's no button to push the user, so it's just asking me for passwords.
Okay, let me open it up here. As Hackathon, I've been using Hackathon. In fact, I was developing another attack on Hackathon just this morning. So
you must have screwed it up.
Well, that would, of course, here's Hackathon. Okay. Oh, it's back to the installation wizard. Wow. Yay. Somebody trashed it. Neat. That wasn't me. Somebody did totally trash it. You're right. Okay, I got to fix that. Wait, what's this restart? Somebody trashed it. I will fix it.
Is there a restore?
I have a restore. I have a saved image.
So with that, so I was trying to do the zap, and would that have messed up?
That would have messed up the zap, absolutely. So, and it's the thing about Hackathon. It does, of course, get hacked. So I have to restart it. I'll just turn it off and turn it on again.
That's just a restore.
Oh, actually, no, I thought I wanted to restore. You're right.
Yeah,
so there is a restore to image. I saved an image of the clean one, and I already had restored it once this semester because in between semesters it gets filled with spam, and the spam fouls up the zap. So that's good. That's down. There should be backups. I have snapshots. There we are.
Oh, my background is scripts.
And here's a snapshot working.
You got some stuff you got to take off from there?
I think this is the one. I think we'll store to this one. There. That should do it, and it'll start. It'll probably take about 5 or 10 minutes. Good. Thanks for telling me. It was working earlier, but somebody managed to trash it in the meantime, which is very easy to do. All right. So let's say those properties of mine get hacked all the time. Of course, that's kind of the point, but it does mean that they're often not working when you need them. Anyway, all right, let's see if I got no real time for the news. I just want to mention the one that was real exciting is Docker. There it is. Doomsday Docker security hole. Docker is running almost everything. All the virtual machines you're running on the cloud are in Docker. All the web applications you connect to are in Docker. Docker saves you so much money that everything is pretty much running in Docker. And people have been very worried from the beginning because the whole reason Docker is so cheap and so fast is that you do not have a second copy of all the files. You're sharing files with the host. And that would make it seem like it would be pretty easy to have an escape attack that leaks out of the container onto the host. And that's what this is. And it turns out to be very simple. And this register article, let me get the register article about it. That's the one that actually gives me some details. There's the register. Well,
Yeah,
it sounds, that's the issue. They didn't just give me the code, but they did describe the code in enough detail that it sounds pretty doable. Here's what you do. You open a file descriptor to proc_self_exe with the opath flag, and then keep reopening this binary a different way. So we should be able to just write that in a few lines of C. If that's all there is to it. I couldn't find it, but it sounds easy. So, I mean, I would like to see it happen. Anyway, ever say you have to patch right away? Apparently it's easy, but there's not a downloadable, runnable public exploit, but this description makes it sound pretty easy. It may be that there's something missing, though. I haven't tried it, but if you want to get it working, that would be awesome. Anyway, so let me move to the official stuff. We are up to chapter 4, mapping the application, and that should be ready to go here. 129S, chapter 4. Okay, there we are. So, all right. I updated a little bit. I haven't posted the latest slides. There's really only a couple changes. All I did was mention which products are obsolete. So this is actually a tedious activity, but you have to do it. You have to wander through the app and find all its functions. Obviously, you're not doing a good security audit until you do that, especially since the weaknesses are usually in some unimportant corner of the app that isn't used very much, because that's where people don't test it and they don't notice that something went wrong. So you do have to wander through every bit of it, and you have to try to understand how an app works. And I think I'll get the hackathon back up. I may demonstrate part of what I was doing today, where you analyze how hackathon identifies you. And that's a simple case where you can see what happens. So you're trying to find the attack surface and the vulnerabilities. The attack surface is all the ways people can feed data in. And every one of those might be a problem. And the vulnerabilities are the spots where you can feed in unexpected data and have unexpected results. So first you have to enumerate your content. The most common thing you do is run an automated spider. A spider is just a program that loads the page and then finds all the links and then clicks all the links and loads those pages and clicks those links and loads those pages until it finds all the pages up to some limit of depth. If you clicked all the links and went on forever, you'd be spidering the whole internet. And that's, of course, what Google and Yahoo and Bing do to make their giant database of the whole internet. But for most of us, we don't want that. We want to just go into one website. So you only look at links that go deeper into the page. And this is pretty easy to write a script like this, and it's included in a lot of products, and that's what Zap does. It is a spider. There's a bunch of spiders that do this for you. The problem is they won't find everything, because there might be content that you can only get after logging in, content that you only get by going through a search engine or something. You're only going to find things where there is a link on a page pointing to it and no barrier like a password or anything. That's the limitations of web application spiders. Now, they try to get through forms. So you'll have a form like a shopping form or a login form, and the web spider probably has some very rudimentary code to put something in there and click the button, but it isn't very smart. So it will get through some forms, but it typically is not very good at getting behind a form because it's not intelligent enough. And I was talking in the other class about this. In 2014, the Carnegie Mellon's Computer Emergency Response Team is very famous and very prestigious. They tested all the Android apps that existed, like 96,000 at that time. And they found thousands of them with vulnerabilities, and they automatically informed all these people. And I came by like 2 years later looking into Android security. I thought, well, I'll just retest some of those apps and see if they fixed it. And I was surprised that a lot of them didn't fix it. So a lot of them ignored the email. But then I found a lot that were not vulnerable in that test that were vulnerable. When I tested them, I said, they actually made it more vulnerable. I checked the creation date. No, it was vulnerable at that time, but their scanner did not find it. And I found it. And I'm no genius. I said, why did this happen? Because they had an automated process. And you had to have a human testing it to fill out the form to get to the vulnerable spot. And that's a big issue here. So human testing is better. So in reality, the human doesn't really bother going to every corner of the app. So you do both. You run the spider to do whatever it can hit, and then you do human testing to verify the findings and to test for more subtle problems that the spider isn't smart enough to. So that's the game. The best tool here is the Z-Attack Proxy. In the book, it mentions WebScarab and Cat, but both of those are pretty much old and obsolete and abandoned. Zap is the new one from OWASP that is the replacement of them for all practical purposes. Now, there are some crazy things on the web. Search engines are relatively new. And so when search engines came out, people said, what if I have things I don't want to be in your search index? Well, I'll put it in this robots.txt file. So the robots.txt has things where you're not supposed to index. Now this, in the first place, you have no way to know that search engines actually obey this. In the second place, this is telling the hackers where to go look. Anyway, it's kind of nuts. A whole lot of the web is like this. They have a so-called security measure that is actually kind of the opposite of security. So this is something to try, especially in CTS and stuff. Always look at the robots.txt. There's often goodies in there. So like I say, automatic spidering has a lot of limitations. It can't get past anything that requires human intelligence to get past, like a CAPTCHA, for example. The whole point of a CAPTCHA is to stop the robots. Only humans can get past it, or that's the goal. It's of questionable value there. Then there's things where you actually have to draw Flash videos and Java applets to get in, and the spiders typically only load the HTML and look for Ahref. They don't really load the videos and play them or anything, so they won't see that stuff either. And the forms, you know, may have validation checks like making sure that the phone number is formatted correctly and the zip code is valid, and your dumb spider will just be filling that all in with like capital A's or something, and it won't get through there. So this is pretty common. And if they see some error like invalid, they don't understand that means something's wrong. They just regard it as done and move on to the next one. Also, they only fetch each URL once. And as we mentioned last time, there's a huge problem on the web that there is no standard format for anything. So there are people, for example, who instead of having a separate HTML file for every page, they have one main page like index.php and then a parameter, which is the file name. So as far as the spider is concerned, they're all the same page. Now, in that case, they wouldn't because it's up in the URL, but you could put the name of the file in like the post data. And then the URL would always be the same, but all the pages are behind there, and the spider would fetch the URL once and say, there, I'm done. And it wouldn't understand that something else that is not in the URL is controlling the page you see. It's one of the many things that will happen that will cause the spider to miss things. You can also have the opposite problem. Some pages have a parameter like a random nonce or a cookie value or a timestamp in the URL, so the page always has a different URL and it's just the same page over and over. So the spider will keep fetching it over and over and over, thinking it's a new page when it's not. That's annoying. And that's kind of what happened to people at Hackathon. Somebody filled the comments page with thousands of spams. So your spider was stuck loading all the spams, so people could run Zap forever. They'd never finish spidering the page until I restored it. All right. And now, if you do have a login page, then you have a sort of catch-22. You could give your spider actual credentials to use so it can get in. Then it can get past the point. The problem is, suppose you give it administrator credentials. It will then go past and click every link on the next page. And some of those pages are things like delete the database, restart the server, that kind of thing. It isn't smart enough not to do that. Some of them at least will not click something that's labeled log out, but they might have a slightly different name. So that's an issue. Your spider can destroy the page. Like, something destroyed my Hackathon today.
Finding the robot, like on Sonic, in one of the forums, and said, "Oh, there's a few robots in this trail."
Oh yeah.
Any projects on, actually identifying the robots?
Well, there are ways to do it. The easiest way is just look at the user agent. Legitimate robots like the Googlebot tell you they're the Googlebot, so you can identify it. This leads to a common black hat SEO technique that Experts Exchange used to do, and they might still do. What you do is you have customers coming in to view your page, and you send them a pay page. You have to pay to see this content, but if it's the Googlebot, you let them through. So Google will index all this stuff. And when people click the links coming in, they'll hit the pay page. This is a cheap form of advertising. Google doesn't like it, and they will punish you if they catch you doing it. But a lot of sites do it. That's why you search for things, click on it, and then you can't get there because they're doing this. They're recognizing the Googlebot and letting it see what you're not allowed to see. So what you can do is view the Google cache, and you can see the page that Google got.
Oh.
But you don't get the images and stuff. But that's one way to see it. Anyway, all right. Also, spiders are dumb, so they will load the pages in the wrong order, and sometimes only a certain order works. Yeah.
Can you put to trick it into sending a Google bot?
Can Bert check to see if it's a Googlebot?
No, can you use a Bert to...
Oh, I think you can customize the user agent. If not, you could certainly do it in Python. You probably can tell it to claim to be the Googlebot. And then it might see more stuff. That would be a pretty good idea. I'm not sure if you can do it in Bert, but you certainly can be done. Yeah. 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 User agent switcher is the one I've used.
So what's the user agent Googlebot?
It's pretty well known. Let me bring it up here. If you just go, it's It's a pretty well-known string. It's pretty obvious. Google bot user agent. All right. There, list of Googlebot user agent strings. Here they are. They look like that. There's a few of them, different versions, but that's what it is. And your user agent is normally like Mozilla version from Firefox or something. So you can change your user agent to one of them. This is like changing the caller ID on your phone call. You can totally do it. It's not verified anymore. And then as far as they're concerned, you're the Googlebot.
Sounds fun.
Yeah. Oh, you can often get to things you couldn't get other ways. That's a common trick to get in. All right. And like I say, the problem is the bot will click all these links, like delete user, shut down database, restart server, which it looks like somebody did online. Anyway, all right, user-directed spidering is more like it, where you have a human clicking the links and the proxy is following you to go where you go. And Burp has the ability to do this. You can tie it to Firefox and then have it follow you. I haven't played with this much, but this is considered the most accurate technique. Here's one thing that happened in previous semesters. My hackathon got hacked. Somebody put 1 million copies of that thing everywhere. I thought it was a dildo, but apparently it's a strawberry corer. I didn't know such a thing existed. I guess I've been eating my strawberries in a barbaric way. I haven't been cutting the core out of them. But anyway, that they filled. Apparently so, and so they filled the comments with millions of those, and they've been up there for a year when I noticed it. This tends to happen. I teach this class, then a year goes by. There's a year's worth of spam. The next semester starts, and I keep forgetting to clean it before class starts.
Do you have a script?
It would be nice, but I don't. Now, actually, let's see if it's back up, because I supposedly restored it from image. And they say it has been restored, so let's see how it's looking now. That's how it was looking, and now it's still looking like that. It is back on. It is back on, but it still looks like that. That's rude.
You just delete the install login. It worked for me.
Good. Oh, thank you. Then maybe it never was broken anyway. Oh, okay. Oh, thank you.
So last time every time I deleted the install login, it wouldn't.
Okay. Well, anyway, now it seems to be back. Good. So, and we'll play with this a little later. I'm glad you bring it up. All my stuff is going down a lot, which I like. That means people are doing their homework. So, let me just see what's up. It was all up as of earlier today. That's why I got this uptime service, and they're all up now. Okay, but you can see. This one was down and that one was down. Hackathon wasn't down long enough to trigger this. The Splunk server is new, so it was down just because it didn't exist until like yesterday. Yeah.
So many issues with automated spiders. People just kind of make their own custom spider and, Python focused on what they need, or do they still use the user-directed?
Oh, I think most people use these automated spiders, but you're just aware of their limitations. The same thing's true of all automated tools, Bowne scanners and everything. You use them, but you have to understand what you've got. Like antivirus, people use it. You just have to understand that it's not doing a very good job. And they do it relatively safe. If you don't give administrative credentials, it's not usually going to do much harm, but you are aware that it's going to miss things. So it's a very good question, and this gets us down to something I may not have mentioned in this class yet, which is arguably everything I'm teaching you is garbage, because we don't have security metrics. We would like to say, your security is currently a 5, but if you spend $1 million and buy this, it will then be a 6, and that will save you this many $1 million of getting hacked. That's what, in a perfect world, that would be security as a science. Security is currently an art. Nobody really knows that hiring better security experts makes you safer. What we do know is everybody gets hacked. The military, Google, Amazon, everybody's getting hacked right and left. So apparently, we're all just worthless. That's why there's a huge boom in this industry. You take classes and get a job. The reason there's a boom is because we're all so terrible at our job that you can hire all the security people you want and it still isn't enough. And so you just throw more money at it because you're tired of getting hacked.
You got the famous last words, inside job.
That too. There are many, many issues. So we're doing this because this is the best solution currently, is to train better people and buy more gadgets and software and put more security stuff on your network. That's what we're currently doing. But in some glorious utopia, this business will actually presumably turn into a science, and there will actually be some way to measure how secure you are and measure how much improvement has happened. We're nowhere near that. Many people are trying to develop security metrics by doing things like counting a number of vulnerabilities reported in a year, and they're all pretty much meaningless right now. It's kind of like a related issue. Like many people are having cuts at the college, firing teachers. And people say, we're going to fire the bad teachers. And I say, boy, that would be nice. But nobody has a measurement system to find out who the bad teachers are. So it's the same problem. Anyway.
It's like a frontier right now, and it's like a scramble online security. You're saying it's hard right now. It's pretty fascinating.
It is. It's interesting, but I mean, certainly you don't want to be too arrogant about what we do. It's not at all clear that what we're doing is any good. For example, H.D. Moore, with Rapid7, in partnership with the Department of Homeland Security, had a highly illegal project where he scanned every server on the internet for vulnerabilities and reported all the findings. It's still going on. It absolutely breaks a bunch of laws, but he's doing it anyway, and nobody's punishing him for it. And the result is he found that like 95% of all the servers that get hacked by using exploits that are like 5 years old. Patching with the latest patches, because most of them don't patch old stuff. They have the same old problem, and people come in that way. Like most of the hacks do something stupid like a default password. So you could argue that all your fancy gadgets and all your fancy staff are not even fixing the real problem. That's why I say, you've been in this business for a while, you inevitably move towards management, because most of the problems are caused by people just doing something blindingly stupid. And the real issue is sort of psychology. Why do our users choose such stupid passwords, for example? If you could do something about that, that would probably be worth more than all the firewalls you could buy. Yeah.
The flip side of that is you did that, right? And like growing several systems, and you spent 4 days trying to get it back up. And
Yes.
Microsoft is clueless.
Yes, that is very, very important. That's the whole point. The reason the old solution was to blame the users. The users are just stupid, lazy bums and don't do what we tell them to do. But in fact, most of the users actually are aware of the fact that your security rules are going to mess everything up. And so that's why Microsoft moved into like trying to figure out why people do what they do without just being mad about it. What is it that makes them do this stuff, and what would be better? That's why, this, that's, governance.
And this is like, it didn't break some like legacy company. It broke like something in 80, which is like another Microsoft problem.
Oh yes, I know that's the problem. When you change the passwords, it tends to break everything. And that's why the NSA started this guidance 20 years ago, telling everyone they have to change the passwords periodically. And about a year ago, they rescinded it. We discovered that this actually doesn't make you any safer. There's no reason to change it unless you actually lost it. And changing it just makes all this trouble for nothing, which is what the users always knew. They knew changing the password just ruins my life, and it doesn't seem to matter.
No, there's a better way.
Yeah.
You just put it on a timer. So from let's say from 11 p.m. to 4 a.m. your account is disabled because you do not have access to your account.
Yes, that's
no reason for you to be logging in at 11 p.m. 4
yeah,
a.m.
and that's part of two-factor authentication, and that's the issue. So having you only log in at certain times and making sure you also have a token, this is the real wave of the future. Your password is not enough. Some other sanity control to see if you appear to be a bad guy would help greatly. Those are all very good features. Anyway, so if we go here, and for example, if I go here and I'm not logged in, then I only see certain items. But if I log, and if I look in the cart, I see only certain items. But if I log in, then I will see more items. So let me try some of this stuff. Let's see if this is going to work now. Let's see if I can get my hackers on to work. All right, so my hackers on is here, and I've nuked all the accounts and everything, so I'm going to sign in. SamTest, okay, I'll make a new user of SamTest with a password of SamTest, that will be fine. I'll type it better. Okay, and I register. Oh, email address, okay. Okay. I can only type. Okay, register. Okay, user already registered. Okay, fine, that one must have been in my image. So I'm going to,
Put a 1 on it.
that's all right, this is fine. I want to be not logged in right now, and I want to choose an item and add to my cart. Okay, now I see something in my cart. I've got Forest Organic Classic Coconut Milk. Okay. All right. But if I log in, Right. This is what I wanted to show you. So let me feed this through my proxy. So let's get my burp up, and we're going to play with this quite a bit more. So this is right on target. And this is what burp is your main tool. That's the whole point of this textbook, is written by the person that made burp. And burp is the tool used by pen testers. Yeah.
In Word, there's an option, intercept on and off.
Yes.
So when it's off, that means the burp is kind of like you're grabbing all the data.
When it's on, when this intercept is on, burp will stop requests, traffic will not go through. When it's off, it lets traffic go through, but you can see it. But if you want to modify traffic, you have to have intercept on. Let me demonstrate this first. This is the most important thing. So first I'm listening on 127.0.0.1, 80.80, which is fine. Let me put that in my browser and let's play with it. So if I go here to preferences, and then I go to the proxy settings, which are here, I can now tell it I'm going to use a proxy of 127.0.0.1 on port 8080 for HTTP. This is what we're using.
All services.
I'm only using HTTP right now, so this is good enough, I think. It is. So the browser, instead of going to the internet, will go to the loopback address and go to burp, and then hope that burp will forward the traffic to the internet. So if I go here and I click a link, like try to add another copy of this to my cart, nothing happens now because burp intercepted it. And so if I go here, see this stuff turns red to get my attention. On the proxy tab, on the intercept tab, in came a request. And now I get to choose what to do about this. I can forward the request, I can drop the request, or I can modify it. So I could modify this request and put like 2 here, and then forward it. And then I could turn off intercept so the traffic will go both ways again. And now I should have added 2 more to my shopping cart. So now I should have 3 of them, and I do. So that's, you can grab traffic on the way out and modify it. And some modifications work and some don't. And that's the fundamental thing you do to hack into websites and to find their vulnerabilities, is to examine and mess with the requests back and forth and try to diagnose how it works. So right now, yeah.
So when you modify the data going out,
yeah.
So you're kind of bypass the client-side validation.
Yes, that's absolutely the point. If there was a JavaScript saying this number can't be bigger than 1, then the browser would only make a request with 1 in it, but I can grab it after it leaves the browser and change it. And this is why all client-side validation can't be trusted, because you could run your script and I could grab the request later and change it, and there's no way the person at the other end can detect it. Yeah.
You're saying Burp Suite is just kind of a standard for kind of that's what you think?
Absolutely. In fact, that's why I teach this class with this book. Real companies came to us as user advisors, and they said, you must teach this book in this class and we will hire those people. NCC, you want to get a job, and several students got a job at NCC, and they seem treating them very well, paid moving bonuses and everything, and they mostly want you to know this book.
So
this is the standard.
Very advantageous to learn Burp inside out.
Yes. Real pen testers know everything in burp. They practice it. They pay for the expensive pro version and get all the fancy features. This is totally how you find vulnerabilities. And even if you do the simple stuff like I do with the free version, I can find vulnerabilities all over the place. It's like I do the simplest stuff to Android apps, and like 80% of them have obvious flaws. It's easy to find flaws out there. Oh yeah, yeah. People, obviously, most people that design websites don't even know this much. And they don't apparently have any layer of management that hires a consultant to find this, and then they get hacked. And so they're very interested in hiring people with these skills to help improve their security. Anyway, so that's the start here. So anyway, another thing I'll bother with the spidering, which is what I was going to show you here. But if I run burp, if I go to cart, user contains only 5 URLs, which I'm not seeing as clearly as I hoped I would see here. But the point is, if I'm not logged in and I run the spider, I only see the surface of the website. If I log in, I see more. And someplace in here, there's something I thought I could show you, but I can't find it. No, this user down here has login, password, and register, and a couple of return URLs. That's what it is. The user container only has an option to log in. Most of it is not visible until you've logged in. So if you ran a spider without logging in on Hackathon, you'll only see this much. But if you log in and run the spider again, then you'll see more stuff here, like log out. So, you know, a small example of the point. You'll see much more of the website if you give your scanner credentials. And the same thing's true of vulnerability scanners. The famous vulnerability scanner Nessus that everybody uses, one of the developers of it was posting on Twitter a few years back saying anybody that runs Nessus without giving credentials is just an idiot. Because if you were to scan your website for vulnerabilities without credentials, it won't even see most of the pages. So it's not going to find the vulns you're scanning for. And that's the point. Anyway, so let me try some Cahoots here. I had them open, but I think I closed them, so I'll open them up again. And turn up the sound. Log in. And go to my favorites, and this is 129S4A right here. Okay. Looks like we're in business here.
It's not really a random number.
It's probably not random at all. It's probably just counting, but I don't really know that. But that would be kind of interesting. That's exactly the kind of thing you test at first. You have any number that matters. You try to figure out, is it predictable? If you can guess somebody else's value, you can probably get in their account.
It's Mother's Day, nobody has a heart on.
There's a heart. Oh, Valentine's Day, yeah.
Yes.
Yeah, of course they do. And they often change the music too for like Halloween and stuff. And today is 2/11/19. Okay. Nancy Pelosi, there you go. Well, you got lots of celebrities. All right, I'll give it a few more seconds to see if we have more customers. Take this time to adjust my screen. People in this room are better off if I don't use the bottom. Give it another few seconds. All right, I think 16 is the number. So what tool will find every page? Oh, that's not good. I somehow killed the, okay, it's better now. I must have hit something.
You pulled the plug.
Apparently so.
Good one, Sam.
Yeah.
That's interesting technique.
Okay, that's of course a spider. Good.
Related.
Good, all right. All right, what part has validation rules? Okay, forms, of course, where you're filling in data, that's where it can check for things like social security numbers being correctly formatted and all that jazz. Which website feature is not a problem for a spider? That's, of course, the point of it. If you have millions of pages, the spider doesn't mind. The human tester would mind. That's what it's good for, just digging through many, many pages. What's the risk if you authenticate as administrator and then run a spider?
No, great.
Okay, that's the point. It might hit the buttons you shouldn't be hitting. This happened, by the way, when the first CPTC, we went to do it in Rochester. A team went out there and we were pen testing a simulated hospital, and they brought down the main server because one of the guys tried using the dirty cow attack, and what he didn't know is there are two versions of the dirty cow attack, and one of them kills the server, and he ran the wrong one. So they had to apologize. They said, you're going to do this pen test, but whatever you do, don't bring down that server. That's what they did. We didn't win. Well, yes. Well, you're not supposed to test live systems that are in use. You're supposed to make like a virtual copy to test for that reason. Anyway, all right. So how do you examine HTTPS requests in Burp?
Cough it up. Or cough it up.
Well, that's it, of course. Yeah. Okay, that's the point. You've done this. You add a trusted certificate to the browser. You tell your browser to trust this burp so it won't complain about being in the middle anymore. And what feature stops all internet traffic? All right, that's intercept, like we saw there. Okay, and let me shrink this a bit so I can see all three winners. There we are, Caitlin, Stan, and WITB. And I now know who WITB is. So, Caitlin. And Stan, I think, is a real name, so that's good. All right, so at 6:42, I think we can go through a little more of this stuff. So if your user guides the browser through the thing and records it through the proxy, then of course the user can log in, enter valid data and all that jazz, and they can avoid clicking the dangerous links. So it makes more sense. And now there's other alternatives out there. You can use Chrome's developer tools where you can view requests and responses in Chrome without a proxy. You just open this page and then it shows you every request and every reply. And the main point of this is not for security testing, but for performance testing. If you load a web page and it loads slowly, they give you a timeline so you can see what part of the page is slow. And then you know what part of the page is the problem to fix. But you can also view requests one by one and responses one by one. You can't modify anything, but it's one way to see what's going on websites. All right, that's the a more detailed timeline showing everything coming in. So there's hidden content on websites. That's the whole point of spidering. There are things you might not go to. So you use automated testing, you use spidering, you try to test it by hand, and sometimes you get lucky. Sometimes you can find the debugging test versions of websites, extra pages that were left in by people that are working on things. I've seen that pretty often. Sometimes they have versions of the website listening on other ports. City College did that for a while. They had a new website on 8080. People often do that. Sometimes they have the old version on 8080 or the old thing like old index or something. And you can go there and sometimes it's still live and you can do things like log in with old passwords and stuff. Yeah. Well, you're not supposed to leave old files on the server, but of course people often do. And that's the point. You should take whatever you're not using and remove it from the server, but of course in the real world, people get halfway through an upgrade and forget things and get rushed off. And so you often have things left on a server that really shouldn't be there. No, I'm thinking of the legitimate developers. Legitimate developers are writing the web page, then they have another version, they put another version, and for a while they have the old and the new, then they activate the new, but they leave some of the old stuff there. Yes, but it's usually no longer linked to a URL, so they think nobody will find it. But if you take, like I went to somebody's site and they had like login3.html, so I just tried login2 and login1, and those were the old versions that didn't have a good password. So that's the point. Sometimes you can just see a pattern in the URL. Sometimes you just try common names. Basically what you're trying to do is get in the mind of the developer, and it turns out that developers are not unique. They pretty much all study the same textbooks and the same courses, and they pretty much do the same thing. Most of them just use exactly what was in the book. Or they go to Stack Exchange and just copy exactly the code and make the minimum possible change because everybody's just trying to get through the day. So that's why people make the same mistake over and over and over. And after you get some experience, you can frequently just guess what name they're going to use for things because they just use one of the standard naming schemes. So anyway, that's a game here.
Can I just download the whole website? You probably
No.
used to be able to download the whole website.
No, this is a very important question. You can't download the whole website because you can't find it all. You can download one page and all the images on it, and you can run a spider and it tries to find it all, but there are files on the server that aren't linked by a link and you won't find them. This is, of course, what Google's trying to do. They're trying to download the whole internet. There is no perfect way to do it. They have to guess what names are there. Front page does not work. It has a thing, it has an option labeled download the whole website, but it's lying. It's only downloading one page. It can't, there's nothing you can do that will 100% download the whole website unless you can log in and make a backup of the server. That would get it all. but you'd have to presumably have to be the administrator to do that. That's a very good point. So now you might find backup archives. This is very common. People back up to the cloud. They often back up on the server. If you can do that, you'll get a whole copy of everything. Another thing that happens a lot these days is people have developed all this code, and then somebody decides we're going to put all that code on GitHub, and they don't tell anybody. The developers don't know that's happening, so all their code is not completely available, and it's got passwords and everything, secrets into code. This happen to thousands of websites. Amazon private keys, because it was in-house, developed by people before there was any GitHub. Then some management decided we're going to the cloud 5 years later after those people are gone, and they grabbed it and put it on the cloud without understanding the consequences. This is usually what happens. What causes all of this is people are not idiots. They're doing what made sense in their context at the time. And a few years later, it no longer is right, but they're gone, and the people here don't understand. That's the most common problem, is that nobody is exactly an idiot, but a chain of unintended consequences lead to a situation that's ridiculous.
What about the archive, Internet Archive? It's supposed to just back up the ones that someone wanted, or does it just still back up everything that?
The Internet Archive makes its own judgment of what sites to back up. I know they don't back up ones that aren't very important. They somehow choose them, and of course they try to get what they can, but they have the same issue. They can't really get the whole site. They will just get whatever part of it they can find. They didn't get like a whole backup, the whole server, which is what it would take to really get it all. All the Internet Archive is trying to do, though, is get what parts that you can see, that you might want to see later.
Yeah, because I think I did that one search one time on one of the websites where you can see all of City College, all the subfolders, like students, staff, whatever.
Yeah, they back up a lot of it,
yeah.
but you can't download all the files. Internet Archive only gets a certain part of the page. They don't get the whole thing. They don't even try to get the whole thing, but they get some of it. And they don't do it that often, and they don't do it for small sites like mine. They only do it for big companies and stuff. They have some kind of algorithm to choose what they think are the important sites to back up, because you don't have a storage space for it all. Anyway, you also might find configuration files, like Cisco config files with passwords that are supposedly encrypted, but they aren't. That's a common one. And I mentioned comments in source code. Log files are often a gold mine. They contain cookies, usernames, passwords. This is why if you read command line commands in Unix, you can often put a password in a command line, but a bunch of people always yell at you, never do that. Even though you have the option to put -password followed by the password, if you do that, it goes in the history file, it goes in the log file. Copies of the password are now floating around. You're supposed to use other ways to do it. But there's always some clown at your company that doesn't know this and gets used to doing it that way. You can also put passwords in the URL to log into FTP servers and stuff, and it's a bad idea for the same reason, because that goes in the shortcuts and in the log files and all over the place. Yeah?
What is
A cookie is just a way to send data to the server, but it does not go in the URL in the browser. It is comparatively hidden. If you save a favorite, it isn't saved in the favorite. And if you make a log file on the server, it's usually not included in the log. So it is safer to put secrets in the cookie than it is to put them in the URL.
So when a bank says I know you're logged in, you look at the cookie.
Yes, most sites do tell you're logged in by the cookie. It is possible to put the authentication in the URL, but it is a very amateurish move, and only the dumbest sites still do that. It used to be common 10 years ago. Now people pretty much avoid it. I remember 10 years ago, the department chair was up here talking about the department chair. They were now a boring faculty meeting, and I saw this number in the URL, and I just typed it in, and I was the department chair. The authentication was just right there in the URL. Our college did it that way. You don't do it that way anymore. Like I said, that was pretty common 10 years ago, and now people have pretty much wised up and said, don't put secrets in the URL. It's a really bad place for them. It's real easy for them to get stolen.
Well, that's the same thing as in the old days when we did internal administration. So you can get to the root of the router even though you weren't administrator internally.
Sure, a lot of things like that happen. So anyway, all right, talked about log files. So you can do brute forcing. You can just try every possible name. So you try, if you find, you find there's a login and forgot password in the auth directory. So you can now run a brute forcer that just tries every possible word there out of a long list of words. That's a simple way to do it. That's a way to find things. Burp has a brute forcer. You can load a word list and it will try all these words. They've deliberately crippled it, going really slowly, like 1 request per second, to annoy you until you pay the couple $100 for the pro version. So it's essentially useless this way. If you want to get the ability to brute force large word lists, you could pay them money, or you can just write it yourself, of course. We do Python in 124 in many classes here. It only takes a little bit of Python to make your own brute forcer. This will do it. This will send a request and try all the words in the word list just as fast as your network connection can go. I mean, it isn't very hard to write a little script in any language you like. If you don't know anything, I would start with Python. It's the easiest language. Yeah.
The Python, the square root is the 4 arrays,
So the square root,
the square bracket.
square bracket. Yeah, square bracket.
The small array.
They don't have arrays in Python. They're lists, but they're like arrays. Yeah, that's right. Square bracket starts a list. Exactly. This one here, I read it from a file. You read it from this file called directories common.wordlist. But you could also put in brackets and list them directly there if you had a short list. And so you can run it, and it will then hunt through and find things. And like I say, it did 2,000 guesses in 50 seconds. So Python runs pretty fast. Yeah.
Give an example of what you brute force.
A definition of brute force?
Yeah, what kind of application of brute force?
Oh, well, I mean, brute force, well, people often use Hydra. That's a big one. The thing about Hydra is it runs multiple threads. That was the professional tool from the Germans. There's a bunch of tools. You can write your own script too, but Hydra is really fast because it'll make 10 threads and make 10 parallel requests. If you're trying like 1,000,000 guesses, it'll try them really fast. And of course, if you're a defender, your application ought to have a detector that sees if somebody's trying to log in like more than 10 times within a minute, you should just ban them. But some people don't, and so they get this. One thing that's kind of funny is one of your homeworks here you're trying to log in, and there's a point where you have a 7-digit PIN. And I have students trying to do 10 to the 7 guesses. It's never going to work. None of my projects require more than a couple hundred guesses. My server's not strong enough to take it. If you have to try like more than 500 guesses for anything, you're on the wrong track. You're never going to do 10 to the 7 guesses against any of my servers. If you try it, it ain't going to work. Anyway, so I got more Kahoots, and I think then we should take a little break. This is 4B. There we go. All right.
I should run that thing and see what number we get.
Oh, running this.
Program.
Well, it is in fact going through Burp right now. I didn't turn it off, but only HTTPS is not going through, which is why it's not complaining. Let's see, I got a chat message up here. Will you be able to tell what happened to Hackathon by looking at the log data? Well, in principle, I could if I had good logs. I haven't bothered to do that. But I just restored the whole thing and lost it. So what I did is what most sleazy administrators do, where you just bring it up without analyzing the problem. So it's just going to go down again. That's why, because I don't really care, because I know what's going on. Not everybody's hacking it. But yeah, in principle, at a professional website, you ought to have better logs, and you ought to get to the bottom of why it crashed and improve it so it quits going down. In my case, I'm trying to make junk to get hacked, so it's not that important. But I was surprised. I was looking in the GenieMD Android app, and I got a Java decompiler, look at the code, and their code is like the horrible code I write. They're actually making bash command lines with user data and Shimoting 777, just doing appallingly stupid things in that app. It's like 1991 era coding. And that's got the Harvard and IBM names on it. Pretty impressive. But it's not their premier product, which just means somewhere in the corner of IBM and Harvard, there are people doing things that the management hasn't noticed yet. That's my impression. Yeah.
My dad went to a night school for law.
Yeah.
And he had to work in the daytime. He said one of his favorite things after he got experience as a lawyer was to beat Harvard-trained attorneys in court very badly. Because he went to this little night school that went out of business, and he said he could wipe the floor with them.
Yeah,
So
yeah.
It's meaningless.
Well, yes, you have a good point there too. The big names aren't always that meaningful.
Yeah, there's a guy in jail that just applied up to the Supreme Court appeals. Yeah. It was all 60 minutes or something.
Anyway, so which tool shows you the timing of the loading of the components? That's developer tools. Has that nice little chart. All right, which tool is ineffective in the free version? Brute forcer is crippled. Which tool shows HTTPS the same way as HTTP? Developer tools are what does that. Anything that involves using a proxy gives you the problem of certificate authentication. So you'll have to add a certificate and tell it it's trusted, because the whole point of HTTPS is to detect man-in-the-middle attacks and to tell you if somebody else is spying on the traffic, which is what proxies are doing. So how do you find all the content? That's it. There's no way. The only way is to be able to look at the server in real time and browse every file in the file system with administrator credentials. There's nothing you can do in the browser that will see it all. And if you look at backups, those are from some time in the past. So, that's why many people get used to putting secrets on the server, because normally there's no way to find them, but you can't count on that. It's security through obscurity. You're just hoping they won't figure out what your name was. So anyway, we got 2 for Caitlin and 2 for WITB. And now we have lottery. We'll have to tell them who they are. All right. That's you? Marshall. Okay, good. All right. So it's 6:57. Let's take a break until 10 after 7, because we got more to do and I want you to stay awake. So I'm going to pause the recording, but I'll leave the share going. Zoom the recording. All right, so let's talk about more stuff in the book. The book is very valuable. So you can then try to find things by just deducing. So if you have a link called forgot password, you can try all the obvious things like get password, reset password. You're just trying to think how their numbering scheme is, how their naming scheme is. And let me see if I can get this thing off the screen. All right, so now I got to guess which buttons will make this big. Okay.
Are these slides on your website?
Yeah, they're all on my website. So anyway, you have numbers and dates and such in a name. If they use something like a number system or date system, it's easy to guess. And you may find file names elsewhere in the source code that give you a clue how their numbering scheme is. You can look for temporary files created by things. This is what Mac creates in every folder, this thing called the DS store. Microsoft Windows creates a thing called thumbs.db and another file for everything. There's temporary files created when PHP is edited. There are temporary files when you edit a Word document or an Excel spreadsheet. And all these things are often floating around on the server.
But
Yeah.
how do you read them?
If you can guess the file name, you can often just load them in the URL. And when you get them, read them at that application.
So a web browser can actually interpret it?
No, the web browser might not interpret it, but you can download it and then open it in Word, for example, for a Word document.
Well, the data is stored in text. But
Yeah.
Oh, okay.
Yeah.
Yeah, I thought they would be smart enough to store it in some kind of proprietary format to where you can open it.
Usually not, because they're not intended to be preserved. They're supposed to remain, but what happens is often things crash and leave the temporary files behind.
Oh yeah, there's lots of thumbs.db files available.
Oh yeah, and those have contained small versions of all the pictures. And
What are those files?
in every directory that has images, there's a thumbs.db. It's what's used to draw the little pictures of it. You'll see it if you view hidden system files. Yeah, and lots of trails create temp folder files. So then you can use content discovery. This is Burt's spider sort of engine that will just try to guess the names by using a whole bunch of rules. It basically automates this process to some extent of trying to guess related names. Skipfish is Google's scanner, which I think is related to the thing they use to find the web. It's very good. You can download it for free. It's not very good at finding vulnerabilities, but it's very good at finding all the files. It really has a good engine to find everything. So yes, you run this against the server and it will find all kinds of stuff on there that isn't easy to find because it's, of course, related to what Google uses. So it's very good at spidering. Yeah.
I mean, the files are open to the outside.
Yes, of course. That's why if you had a file that the whole world shouldn't see, you should change the permission so they really can't see it. This will only find things that are using security through obscurity, where it's in fact visible, but they're hoping you won't find the name. And
Is it the
that's,
resource log?
no, I ran it, no, ran pretty well in virtual machines. It's really quite fast. You know, Google does high quality stuff. Yeah.
Android.
Well, Android is surprisingly bad, but the coding in GUS is very good. You're right. Anyway, so Dirbuster, see it's a band, but there's a new thing called Dirb you'll find in Kali. I've used that a lot. It's really quite powerful. You can run it in the command line. It will, if I don't know about Windows, but you can, this is in Kali, and you can totally, it scans through things, finds a lot. I've caught a few CTFs this has worked to find a hidden file. It tries a capture the flag contest. Well, you do a lot in security. That's how most of the training works. There's one going on right now. I think Easy CTF started.
Isn't it starting next this weekend?
I think it's already started. I think it started on the 10th.
Why am I not doing it?
I know. Why am I not doing it too? I got distracted by other things. But we should all be doing Easy CTF. Yeah, it's the 11th. So it's going, yeah, we should all be doing Easy CTF. It's good for you. It's worth extra credit. Yeah, apparently it started yesterday. Yeah, I did not do it. I forgot about it, but
Here's some stuff right into the lab.
it would be awesome to do. Anyway, all right, then there's, of course, public information like cached pages, information on the Wayback Machine and the Google that has information. People post things, and you'll find clues there about files that exist. And things, some of these things, like I'm not sure if Derby does, but some of these will actually go to Google to find names and try those names. You know, they'll actually include that open source information. Google itself has a lot of nice advanced features. You can search within a site with site : you can search for certain things like login. One thing I did years ago when I wanted to post stuff about this at DEF CON is I went and searched for how many plain text login pages there were at colleges. And I could do it on Google with site star.edu login and protocol HTTP. You can specify all that in advanced search. You can find a page that is not secure and has the word login on it and goes to a college. And I was able to go through those and find a bunch of colleges with plain text login. You can do a lot of that stuff here. Now Google is getting fed up with this, and if you do that and search on like the 4th or 5th page, it will start popping up captures and say you appear to be some kind of evil person doing something nasty, and it try to harass you more and more for like obviously not seriously searching for something normal, but trying to find a vulnerable page to hack, which is totally what I'm doing. And they do catch you more and more at it. So you can often see the directory contents in raw source code and scripts on the page that will have clues, and there are scanners just for web vulnerabilities. Nikto and Wikto are very popular because they're very fast. It's really not a very thorough vuln scanner. It tries for like 30 or 40 well-known weaknesses and finds them. You'll find Nikto goes quite quickly. So you run Nikto on, say, Hackazon, and it tells you right away a few things. It always tells you kind of boring things. Like here it tells you about a cookie that doesn't have HTTP only and stuff like that. Not really exciting stuff. Didn't find like the SQL injections or anything, which are on that site and really awesome, but I found a few minor flaws. And it is fast anyway.
Who made those programs?
I don't know. Somebody wrote it. They're all the same. Some guy put it on his open source thing. It's usually just one guy that made it and usually forgot about it. Occasionally, they were motivated enough to update it for a few years before they get bored with it. Often they end up owned by companies. Often they have their own company. They get bought up by somebody. Like a whole bunch of things are owned by McAfee now.
Oh.
Anyway, so then you got functional paths. Like here, I go to bank.jsp, and down here there's a bunch of information that's actually going to end up in the path. But it's in the funny place. It's in the post data, but it's actually information from the path. So that's very different to scan, and many of your spiders will not understand how to scan this kind of structure. That's the problem at the web. People have these non-standard structures. So the actual functional path is I'm here, then I can go to transfer funds, then I can go to confirm transfer, and it's all got the same URL. So your spider would be confused, but an intelligent device like a human would be able to navigate through it. So there's hidden parameters also. We're down to what you were asking before. If you are hidden, you might try adding debug to requests. They often have this mode for the developer to work on things. Burp can do this automatically. So you try to find the core functionality, whatever the main purpose of it is, like shopping or something, and then the offsite things like password resets, connections to other sites. I had a whole bunch of Android apps, all the Android apps that went to the major colleges, the U.S. Air Force Academy, West Point, the Naval Academy. They were all vulnerable in their connection to offsite content. I was able to steal Gmail passwords, Facebook passwords, Twitter passwords from inside those apps because their link that sent you to go tweet about West Point was insecure. So this is often the case. These peripheral parts of the website are not safe. Anyway, all right, and the main thing, of course, your attack surface is any place where the user gets to put in data. That's where the user might put in malicious data. So names, passwords, anything in the query string, post data, cookies, forms, and so on. All these places where data comes in can be an attack spot.
I think your power plug dropped.
My PowerPoint dropped.
Plug.
I don't know what you're, okay, it doesn't matter. Anyway, all right. You've got a lot of stuff happening on the server, many components up there about which we'll talk a lot more later. There are a bunch of attacks that do not directly affect the first server you hit, but they have an effect when you get past to the next server. And like you say, oh, this is your attack surface, everything that the user can feed in. Things like the user agent and the referrer, any part of the web request can be used as an attack, not just the part you see in the form. And you've got these RESTful URLs where there are things that look like a path, but they're actually parameters. So putting in things like apostrophes could lead to SQL injection and such. And here's typical request parameters, google.com *Q equals duck. Duck is called the query, but that's the standard way to do it. But people do all sorts of foolish things, like use semicolons, use $signs as delimiters, put weird punctuation marks as delimiters that get URL encoded, and all these get used by people who write a script at the other end, so it's pretty annoying. Any assumption you make is only going to be true a certain portion of the time. You've got headers in the HTTP request. You've seen them. There's several lines of stuff going up there, and you could put stuff in like user agent or in refer in other parts of the request, which they may be processed unwisely at the other end. If you are behind a load balancer, which almost all large sites are, you go to Google or Yahoo or Amazon, they don't have one server. They've got a whole cluster of servers, but first you go to a load balancer, which just takes the request and sends one to this one, one to that one, one to that one. So it's like a proxy. It's called a reverse proxy, something on the way to the server. And they often use an X-formatted for header so that the server knows that it came from the proxy. And you can often manipulate that to reach a specific server and to eject content. We'll play with those a little later. At least we'll look at them. You have email. There's other things that come in, not from the web request. Emails, things like WebDAV, where files are automatically loaded to a server. Your IDS often sniffs traffic and then puts it in the log. So you could attack the server by sending traffic, which will put malicious stuff in the log. You know, all the data is coming in by various techniques, and anything that ingests data onto the server is a potential attack vector.
How do you attack the log data?
Well, if you can put something in the log, you can sometimes inject code and then run it by browsing to the log in the browser. There's a variety of attacks that work like that.
Browsing the log in the browser?
Yes, the log is available to the browser, and you can sometimes put like JavaScript in there and sometimes even PHP in the log. It's not that common anymore, but it has happened. All right, and I would like to make this small. If I can only figure out what button to press. There we are. Somewhere down here we have cahoots. And there they are, 4C. All right. And I think I'm going to make 4C as far as we go today. I'll leave a bit for next time because I do want to do a little demonstration rather than more of this stuff, which I think is kind of deadening. Good.
It's more fun if you run two cahoots at the same time and see if the next number follows this number.
It can't.
I'm
I
with
mean,
you.
I know, but look at how high the number is.
Well, it's worth a test. It's an interesting issue.
Representation test.
You don't know until you try.
Sometimes I'm right.
Yeah.
All we have to do is have someone log in using
Well, I remember I was in an experimental scientist many years ago, and you learn that you have to try everything. Even the stupidest thing, you should not reject it until you try it. Because often things are simpler than you think they're going to be.
There's a variable that, every time I cross over, it says, oh, I changed the variable.
So you don't trust your intelligence then?
I know, your intelligence very often deceives you. It happens to me all the time. I think I understand it, so I don't try something. And I didn't understand it as well as I thought, so that was actually going to work. That was. Yeah. Well, you know, my impression is the programmers are logical, but you don't really understand their constraints. So there's a reason why this actually made sense in some context, even though it looks ridiculous now.
You know, if I assume that if I don't assume that the programmers can do something, you know, ridiculously insecure, then I haven't.
Well, yeah. Anyway, let's try this. All right.
That's not smoke.
Try one of these, now I'll demonstrate something about hackers on that might be fun. All right. So which one of these came from Google? Okay, skip fish. I don't know where to get these names. Anyway. Which system might put data snipped from network packets into a web app? Okay, that's IDS. Your intrusion detection system might take incoming data and put it in something that then goes into the web app. It's a side channel attack. There are a lot of cool side channel attacks, especially in cryptography. All right, so which header might expose private data from one website to another website? I was very surprised when I learned about this. It's very rude.
It's common.
Yes. The referrer tells me where you came from, which in my opinion is none of my business. I could totally look at my web server and see how many students are viewing like a porn page and then go to my page. And I don't know why I have the right to see that. But they put the referrer on every page. It tells me what the previous page was in your browser. And if that previous page put secrets in the URL, I would see them. It would be leaking passwords and cookies and everything. That's why you should not be putting secrets in the URL, even if you're transmitting them over HTTPS, because the whole logical structure assumes that they can just spray that user URL everywhere and it's okay.
What if I open a new tab?
If you open a new tab, I think it won't count. That's like a new page. But you should test it, and I wouldn't trust it to always be true. It's just a question of how they built the browser.
Okay.
All right, and which one's a Bowne scanner that runs on Windows? Oh, your Kahoot goes up. Your Kahoot crashed. Well, you got hosed. So that's Wicto. Nicto is the original, and they made the Windows version and called it Wicto. Anyway, so, and Caitlin did not win, probably because her app crashed. So that's why this thing is extra credit, because it's massively unfair. So I now have.
It's probably just the drugs.
M,
That smoke.
Yeah.
and B. B will have to tell me who they are. But now let me show you something which is kind of fun. So let's figure out how Hackathon knows who you are. This is part of a project that's going to come around later. I'm working on it. But let me show you as far as I got here. So if I go to Hackathon, which is one of these tabs here, if not, I'll have to open it again. All right, that's fine. Hackathon. Okay, here's Hackathon. Okay, now, I am not signed in right now. So let's clear this old stuff. And now let's sign in. I made an account called SamTest and SamTest so I can sign in. Now let's go see. So now I'm on a page that is my page, and I can go to say your account, my orders. Okay, so I'm on my page. Now if I look in the browser, in the proxy, you see what happened here. Here's the login process. I have a post request, and this is what set up my name and password. So it sent that up to the server with all this blah, blah, and my name and password. Then the server replied with this response, 302 found. Now a 302 is called a redirect. 302 means you have to go to another page over here, location account. And it did not set a cookie or anything. which I thought is very strange. I send it the name and password, and it just redirects me over to this /account page. So the next request, my browser goes to the /account page, and now it does not send up the name and password anymore. But it sends up these cookies, visited products, CFDUID, and PHP SESID. It sends those cookies up to this page, and this page sends me a response, which again does not set a cookie, but it has HTML in it. Now, if you have a page that does respond with HTML, you can actually render it in the browser here, and it'll show it to you the way a browser would to make it easier to see. And if you do that and scroll to the bottom, it's got my name, Sam Test at Mailinator. So I'm now logged in. It knows who I am. So this is a sort of screwy process. Now, the normal process is I send it a name and password, and the server sends me a cookie. That's my ID card. Now, with every future request, I send that cookie, and it knows who I am. What happened here was a little screwier than that and kind of weird. So let's try something else. There's a few things I might want to do here, but right now, I'm just going to know, how does it know who I am? Somehow, from this request, it knows that I'm Sam. So to test this, the easy way to do it is send this to the repeater. This is one of the awesome things in Burp. Repeater, you can copy any request and go to the repeater, and now you can send modified copies of that request. So here's the original request. So if I hit go, it sends it over here, and I can render it, and then scroll to the bottom and see if it knows who I am. And it does know who I am. Now, this was worth doing because it might have anti-cross-site scripting protection, anti-CSRF protection, which means you cannot just repeat a request. Part of it can only be done once. But this site does not have that. If I steal my request and just replay it a second time, it still passes. So now the question is, what part of this was used to identify me? And here's the easy way to tell. You just modify the request. So there's a 9 there. I'm going to change that 9 to an 8. And then I'm going to send that request. And when I do, it still knows who I am. So apparently this CFD UID number does not matter. So maybe I can just throw it away entirely. So let's try that. If I just delete that part of the cookie entirely, and I guess I'll get rid of the extra space, although I don't think it matters. And now I send that. Let's see what I am. It still knows who I am. So apparently that cookie doesn't matter at all. That cookie is for something else. I happen to know that cookie is for Cloudflare, which is not even for Hackathon. So Hackathon server couldn't care less whether that cookie is there or not. Now I got this thing called visited products. That's probably just what's in my cart. That probably doesn't matter either. Let's try taking that out. This is how you track down what part of the page matters. You go throwing away parts and see when you're no longer recognized. So if I throw away that one, I'm still Sam Test. So apparently this one is the one that matters. And to find out, it ends with 2. Let's change that to 3. So if that cookie value is 3 and I go, now I get a totally different answer. So now I forgot who I am. Now, apparently the cookie is your ID card. So this means if I was able to guess somebody else's cookie value, I could get in their account. So if this cookie value was short, like the Kahoot number, only a few digits long, I could probably just guess a number. This is really long. If they're using proper randomization, I'll never be able to find it. But that's not what's happening here. It's not a failure of randomness. This is another vulnerability called a PHP, called a session fixation vulnerability. And here's the thing. This number is 747I3. The problem is, if I log out, let's do that. Let's log out here. Okay, I'm now out. It doesn't know who I am. Now I'm going to sign in again. If I sign in again, let's see what my cookie value is now. If I go to Proxy History, and I go down to the second login here, and the second get. This is the request. It sent a cookie up. This is, I think it has changed now. Last time it was the same. But anyway, what I wanted to show you is the process. If you go here, when I sent this first request, there was a cookie in my browser before I logged in with this number. And the server just used that number, which came from me, instead of assigning me a new number. This is cookie reuse. And I did a whole thing at DEF CON for years. I saw how many websites did this, where you use a cookie, and then when you log out, the old cookie keeps working. Microsoft Office 365 did this in about half the sites on the web. This means if I steal your network traffic or your phone and I get your cookie, you're hosed. I can keep getting in your account forever, even when you change your password. The only way to get rid of me is to delete your account. This is very unsanitary, and many websites do this. The logout button just clears the cookie in your browser, but if you make another copy, you can just keep using it. Some popular frameworks do this. I don't really know why from the developer's point of view, but this has an even worse vulnerability. I fed it a cookie value, and it just used it. So now I can feed it a malicious cookie value. So let's go to the repeater. Let's take the login post and send that to repeater. And now, if I log in with a valid username and password, I will get a 302 found sending me to account. And if I then go to that account and feed up this cookie, it'll say, know who I am. So what I can do is not only remove the cookie value that doesn't matter, these ones don't matter, I can change that number. And I tried before, I can change that number all the way down like this to 10. So I'm going to feed it a cookie value of 10 and log in with a valid name and password. And when I do, it does not return me a cookie value. It just accepts that as my session identifier. So now I can go back to this one, which gets the account from that place, and I can feed it that number, 10. And when I do, it recognizes me. This is called session fixation. I can't steal somebody's cookie, but I could send them a link that causes them to log in with a cookie value I chose. And the server will just go with it. So I tell them to use this cookie value and the server buys it. That's kind of nuts. But this is one of the well-known vulnerabilities. And it becomes, you can see all these vulnerabilities are going to be the same thing. The developer uses a number that really did not come from the server. Ultimately, it came from the client. That's the fundamental flaw. But it's hard when you're a developer to realize where all your data came from. They think this cookie came from them, but it actually bounced off the client. And they're actually, when they went there, they say, oh, if the cookie is already known, don't give it a new value. And they don't question, why is it already known? This is the login page. I shouldn't even care what cookie's coming up right now, but they aren't thinking of that, probably because they're at a different server, a different part of the infrastructure, where it's possible that someone would hit that function from some other part of the site where you're already logged in. So they just say, if you already have a value, that means you're already logged in. I don't need to assign you a cookie value. You'll see this kind of thing happen a lot. Anyway, that's what I wanted to show you. What's that? Well, oh, this one is kind of annoying. Now, what I could do on some websites is I could put the cookie value right up in the URL, and then I could send people a URL to click, like in spam, and when they click on it and log in, I've got their cookie value. This one here isn't that vulnerable. I can't put it in the URL, so it's actually pretty hard to exploit. I'm planning to do it, but I was thinking I might not write up the rest of the project because now it gets complicated. What you have to do is go to cross-site scripting and inject it with JavaScript. But it gets kind of complicated. I try to make projects with simpler cases than that. I might write my own server with the vulnerability I was hoping for here. But it does have session fixation. It's just not so easy to exploit. If you would let me put it up in the URL, it would be easy to exploit. I could now make a crafted URL, and that, so I might write that one or find a way to modify this. I already modified Hackathon a couple times. It's actually pretty easy to modify. The original Hackathon, some of the SQL injections were broken and I fixed them. And they're supposed to pay me $10. I think they never did, but they said they pay you $10 if you fixed it. But anyway, maybe I'll find a way to modify this so it'll let you put the value up in the URL. It's really pretty easy. You start contributing to open source projects. You don't have to be a genius. They're pretty easy to read. You find something. Anyway, so that's what I wanted to show you. That process is good. And the last time I taught this class, I was going into Pac Bell and PG&E and stuff. It's Comcast. Comcast had this deal, Kurt pointed out to me, where you can pay your bill from home and you don't have to log in. It recognizes where you are because you're at home. And he said, that looks vulnerable. I said, yeah, it sure does. And I was able to do a lot of this stuff on the Comcast side. I didn't really get to an exploit that was awesome, but I was able to do a few things that were not kosher, like this right here. Because, you know, if it lets you get in an account without really logging in, that doesn't sound right.
So my favorite is resetting their internet. Yeah,
you reset their internet. You can do that. So, you know, it's real websites from big companies have a lot of these little bogus parts. And often they're not bad enough to really do anything too bad because there are other layers of controls, but you can often find these defects. Anyway, I think that's it, unless there are questions. All right, I'm going to stop the share, and then I will go upstairs and help people in the lab for a while. All
All
right.
sound was saved. Did that thing unplugged? I didn't unplug the sound, right?
I don't think so. The sound is over here.